Well, welcome to this talk. I'll try and talk about a few of the important things I experience when we talk to clients and then, when we're talking to customers and visiting enterprises and so on. I've tried to synthesize a lot of those questions in the form of three different stories, which will span in three different times and ages almost. My first story is set in 1850s, the second one in 2000, and the third one in 2016. I'll also try and bring another aspect of AI, which is fairly important, which is an aspect that it's changing the way we live, work, and think about our lives. Right? Of course, all this is fairly normal. Everybody expects all this to happen, but at the same time, it's fairly important to see and dive into the specific stories to see the value that it brings to us. So I have structured this talk in the form of um, topic, which I've called the three doors to AI, the three separate doors to AI. It's sort of based on this idea that, typically how does the AI process really work? So it starts usually with somebody acquiring data. Well, there is a step before that. The step before that is that you believe that you can solve problems using data. If you don't have that belief, then obviously the first step is not going to happen, right? So I'm assuming that you have the belief that data can actually solve problems. Now, given that, the first step is you have to acquire data, right? Most enterprises have data, right? Because they're building something of value. And in the process of building something of value, they're sitting on data. So it's not like enterprises have to go out of their way to collect data. They actually are sitting on it. So that's the first step. It's sort of given to most, given as a given for most of the enterprises. The second step is you have to understand the data, right? Now that act of understanding brings insights, and that insight helps in decision making. So naturally, the first step you've done is collect data. The second step is you have tried to understand the data, and it has started bringing you insights. You already are in the process of implementing and getting towards AI. The second step after that, or the third step, is to organize that data in such a way that you can achieve specific outcomes. So, gather data, understand data, organize data. That's the third step, right? And the moment you start thinking of organizing data, you started thinking of efficiencies, operational efficiencies that will bring value or make your value more tangible, more significant. With that step getting completed, we get to the fourth step. Now, this is a step which is not talked about a lot, but it's, in my mind, the most significant aspect of AI. That is called making data actionable, something that you can act on as a result of that. So, these are the four steps, and my talk is going to walk you through these four steps: get data, understand data, organize data, make data actionable. So, here goes. Our first story is based on this idea of being able to look at insights, the first stage of understanding data, and see what value can come out of it. This story is based on this guy. His name is John Snow. I don't know if any of you have heard of him. Have any of you heard of him here? John Snow. He's, in my mind, the first data scientist, although I think Johannes Kepler was also pretty close, right, in the early 1600s, or 1500s, late 1500s. But John Snow is a data scientist. He's living not as a data scientist, but as a guy in London. And this time is the 1850s. London is having one of its worst problems as an urban city. The population of London has grown tremendously in the last 50 years. And, over the 1600s to the 1800s, the population has almost quadrupled. The city is not geared for all this. The number of people who live in this city, the density of that, the number of people in a room is 5 almost, and there are about 450 people per square kilometer. This is almost comparable to Bangladesh today, for example. That's the kind of density that this city has. And worst of all, the sewage system in London is not really there at this point of time. So this is our setting. This has actually happened, and this is what this story is actually going to unfold, right? Now, London has had its first cholera epidemic in the 1800s. A baby died in the early 1800s out of this disease called cholera. in the next 20 years, there were 20,000 people who died because of this disease. And in the 1840s, there was a dramatic epidemic, and almost 50,000 people were dead in this city. Right? And all of this happened in a couple of years, almost in the 1850s. Now, interestingly, those days people did not believe that cholera was caused by water. They had no science. Microscopes were available, but microscopes were not sharp enough to identify a bacteria like Vibrio cholera, which is the cause for bad water, which causes cholera, basically. Right? So people believed that cholera as a disease was caused by bad air. And this was very normal because when you go into mines and you inhale these poisonous gases, you get sick. So it was pretty common that, there is this thing called miasma, and the word given to it was miasma, which is what causes this disease called cholera. Now, John Snow did not believe that. He had very specific reasons to not believe that, and that was because he had a belief in data more than in just intellectual idea, for example, right? And John Snow was thinking about, some very interesting ways to approach this problem. This is the map of London drawn from the 1850s, and the different colors indicate the different ways water supply was provided to the different neighborhoods in London. So John Snow drew this map for himself, and he started collecting information about the actual deaths that were happening in the city. Interestingly, he came across this first statistic, and this first statistic was that, if you lived in the northern area of London, the chances of you dying were much lesser of this disease than if you were living in the south city of London or the southern area of London. And Thames was the river which basically demarcated the north and the south. Now, in our data science parlance, we call this aggregate statistics, right? Average. How many people on an average died in this area versus that area? And just by looking at this average number, John Snow had a clue about something fishy going on. Now, if this was air, why would air make a difference between north of Thames and south of Thames? Right? It seemed odd to him, but not to a lot of people who were living in London in those days. They just did not buy this thing. Right? They said that this person furnishes no proof whatever of the correctness of his views. This is the London Medical Gazette in 1849 publishing this article. They are talking about John Snow, and they say that, his views have no evidence whatsoever. Well, they also suggested an experiment to sort of verify that such a thing could really happen. And they said that, one way to verify this would be if somebody who was not living in the same area was made to drink that water and they contracted the disease, then that would be like the absolute verification. Now, of course, you can't do this experiment really, right? You can't just take cholera and go somewhere and say, you have this drink and we'll do this little verification. But nature has interesting ways, right? And we can go about how it really takes shape and why nature takes its course if you didn't follow the signals. 28th August 1954 happened to be one of those very interesting days. A baby by the name of Frances Lewis, she is 5 years old. She lived with her mother in this area called 40th Broad Street in London, and she contracted cholera. Her mother, after washing her diapers, took the water and threw it in one of the cesspits close to that place where they lived. Very close to that cesspit was a water well. Now, this cesspit did not have good protection, and so that water leaked into that water well. And very soon, about 300 people fell sick and died in the next 2 days. So 30th August, about 300 people were dead drinking that water. Now, of course, I am saying drinking that water. At that time, it wasn't very obvious how these people were dying. But all these people were dying in that same neighborhood. That's about the time when John Snow realized that this experiment is automatically and naturally happening, and I need to participate in this experiment to really verify what's really going on. So he went to that well, he collected water. He went to four other wells, and he collected water from all these 5 different wells. He put them under the microscope, but he couldn't see anything. Right? Again, the microscope were limited in those days. So what did he do? He went to, and he did the next best thing. He walked to the registrar of deaths. Now, London had created this whole registration process, 20, 30 years ago, where anybody who was dying, they would make sure that, all that information was collected at this registrar office. The cause, the time, as much of it could be known was put into those records. So he walked up to this registrar office and collected 83 observations of people who were dead from this disease in the last 5 days. And then he went and started plotting this information on the actual map of the city of London where this all was happening. So here is, for example, the number of deaths in this house, and the area and the length is sort of reflecting the number of people who've died in that house, right? That's the same map, but just colored differently. But you can sort of see that he has something what is called a data distribution. So once you do aggregate statistics, in a data science parlance, we do something called data distribution. We try and understand how data is distributed. He is the first data scientist. He doesn't know all these rules. He has not read any book. He's just trying to solve a problem, really, right? But what is he really doing in the process is something like this. Now, he is fairly comfortable now. He's seen a lot of information which is confirming that this is basically all located around the same area, and this water pump might be the actual cause for this thing. So he goes into a deeper dive about finding all these specific stories that are maybe of importance. One of them is that there were 3 children who did not live in that neighborhood but had died. So he went and interviewed their parents and found out that these 3 children went to a school which was in the 40th Broad Street. So he was able to collect and confirm that there was a way for him to relate this death to this water well. There was another interesting situation. There was a pub, a brewery in the 40th Broad Street area, and nobody had died in that brewery. Any guesses of why that might have happened? Right. Very obvious, yeah? People were drinking beer more than water and got saved. They did not drink of that 40th Broad Street. There was one interesting incident of a woman who lived really far away again from the 40th Broad Street but had died. And what had happened was, when he interviewed that family, was that she had grown up in that Broad Street area and had started liking the water from that 40th Broad Street pump in so much that her children had arranged for a water supply every day for her. And she had this water and she died on the 5th day. All these things basically resulted finally in the city agreeing that they are not really sure yet that, that cholera is still caused by water, but it's just too much of a risk to not close that water well. And John Snow finally got that water well, that infamous water well, to be closed, and the deaths stopped. They made a pub in his honor, and it still stands today in London in the name of John Snow, who was basically single-handedly, by just looking at data, stopped cholera deaths. He was not a doctor. He did not understand cholera, but he took a belief in data and used data in a very powerful way to solve a problem. And the City of London basically, stopped the epidemic, which was flowing indiscriminately, got sort of curbed because of this discovery. So this is my first story from, 1850s. It sort of talks about the idea of and the importance of data. And, very naturally so, I found this cartoon on Google Slides, so I just borrowed it. But the idea is, that as organizations, we are thinking a lot about data. We are thinking of data warehouses. We're thinking of data lakes. Of course, we have to think about all of this stuff, right? But at the same time, it's fairly important that we think about things like data quality. We think about things like metadata. We think about things like catalog, right? Because pretty much all the important synthesis that you're ever going to do on this data lake, data warehouse, is going to come from these ideas of how are you intending to use this data. If you don't think about that and you say, just put everything there, then of course, that's good for now, but sooner or later you will have to, think about those ideas. So my first story is just an idea about, that data, while you have to think about all the platformish technology and the rest of it that has to go, please also think about how you intend to use it. Don't divorce the idea of using it from storing it in any significant way. So that's the first story. My second story is about, how organizations, once they have had this understanding of data, are leveraging that data to take it to the next level. Now, this story comes from this application that was created in 2000, a website, a web application called Donorschoose. This website was started by this guy called Charles Best, who is a school teacher. And he was constantly helping his students, get different kinds of things which he thought would help in their education. One of them was getting them access to good books. And good books were not a dime a dozen. So what he would do is he would take a book, photocopy it, and Xerox it and give it to his students. Now, he would spend his own money doing something like this. And he realized that there may be lots of people in US, in America, who might be willing to support something like this, right? If he could only find a way to connect with them. So he goes ahead and he builds a website, which is called donorschoose.org, and he puts up, his ideas of, all good? And he puts up his idea on this application, and he says, here are the few proposals that I would like you all to fund. Very soon, he's flooded with a lot of different people asking for, I have a proposal, can I get funded for this? I have a proposal, can I get funded for this? And a lot of people who are willing to pay, I have $50, I would like to give it to you. I have $25, I would like to give it to you, and so on, right? Very quickly, in a matter of 6 months, he synthesized a community where people were actively wanting to participate in a process like this. Now, the way he used to run his operation was he had volunteers. He is a school teacher. He doesn't have funding at that level, and nobody really believed in 2000s, people were not, venture capitalists were not investing money in education, at least, not when it came to things like this, right? So he's got a problem, and he doesn't know how to scale up this application anymore. His idea is really awesome, but he doesn't know what to do taking it forward. So he gets all these people together. He trains them in a room, and he says, I'll teach you how to basically process a proposal very, very quickly. So, there are lots of volunteers who are sitting and they are looking at proposals and saying, oh, this proposal is very important, this proposal is not that important, and so on, right? And different people have different ideas of which proposals are important and which proposals are not important. But in the end, it works for him, right? He has a problem, he's found a way to solve it. The way to solve it is through intelligent, empathetic people who are willing to give their time to solve a problem like this. But again, even after this stage of execution, he doesn't have the ability to really take it to the next level. And so this is the time when he starts thinking of, what technology and how technology could help him do something like this. So he comes up with this idea of a virtuous circle, right, of how he would really go about doing something like this. So he says, my first thing is, I am going to organize a proposal form, which will be my basic input to how, how somebody will assess that proposal. So he comes up with a structure of a proposal, and he says, this is going to be my data set, and this is going to be my basic raw data set. Then I'm going to use some mathematical model, which will get applied on that data set, and it'll curate out and basically, rate the proposal in terms of priority. Oh, this proposal is fairly important. This proposal is not that important, and so on. But I'll make an algorithm do it. I will not let people do it, right? And this is what he's thinking in 2000, right? And finally, how am I going to use it? Oh, so if a machine gives me a proposal of, very important priority, and the machine is fairly confident, I will just take that proposal. But if the machine gives me a proposal which it is not confident about, I am not going to put it away. I am going to give it to a volunteer to screen and double check it. So I have a system where the machine's outcome and the people's outcome are cooperating or complementing each other in an interesting way. So this is his thought. So he goes about and he creates this interesting data set. He identifies specific features that he thinks are fairly important for the model to analyze before accepting or rejecting a proposal, right? This is the first step. The second step is he, with the help of machine learning engineers in those days, and machine learning, believe me, was available in the early 2000s in different ways, he builds a model, which works very well on this data set. And he's also able to understand why a certain proposal is better than the other proposal, right? So he's able to analyze and understand. It's not a black box for him. He's able to see why the machine is rating this proposal higher than the other proposal. Something that gives him confidence as a result, right? And as a result of all of that, he's able to build a system which today is working at these levels. He's supporting a transaction of $864 million every year through this system, right? And those are the stats that are up there that you can see. There are about 83% of public schools in US which have posted a proposal on that website, right? These numbers are staggering. I mean, just look at this number, just coming out of a simple web application, using an automated mechanism to filter proposals. And this mechanism is devised by a person who is not a machine learning engineer in any way. But this is my second story because this sort of shows the power of organizing data in a very interesting way, right? And you can actually solve very amazing problems as a result. He is doing all of this with the help of 110 staff members only. Look at the efficiency again, right? The kind and scale that he's operating at, right? And this is again a natural process in AI systems, right? You start with understanding data, but at some point you want to leverage scale because that's what AI gives you eventually. And how to really do that is where all the science basically lives effectively for us. So I just want to talk about that when you do something like this, you have to be very careful about not just getting stuck on ideas of metrics. The goal is not really to say, is it 85%, is it 87%, is it 99%? The goal is to see whether it is helping your business move in a direction, slowly maybe, but nevertheless in a way so that you can actually achieve your business outcome, not necessarily your model outcome. So a lot of times we talk about AI and a lot of situations are about, well, how do you do with, 80% or 70% of how, when your accuracies are only at this level? We find very normal ways to take even 70% of value that a machine learning model gives us and turn it into gold, pretty much, right? Without getting stuck up on these metrics. So this is one of the things that I thought I'd share about, this particular story. Finally, the third story. This one comes from India, and I am involved in this story partly, so I thought it was fairly convenient for me to just talk about a story that I was involved in. This is a story about diabetic retinopathy. Diabetic retinopathy is a disease that causes blindness. A lot of people in the world who have diabetes are at the risk of, becoming blind because of this specific disease. And it is one of the major killers or blindness-causing diseases in the world, and especially in third world countries, and of course, in the first world countries as well, right? There are about 93 million people worldwide who are expected to have this specific disease that would cause blindness. Almost 40 to 45% people who have diabetes have this risk of being, of having this sort of disease. The mechanics of diagnosing this disease is fairly complex. It's non-trivial to diagnose this disease. So ophthalmologists have to be really, really aware and experts to be able to diagnose a disease like this. And again, if you look at a third world country like India, the ratio of people who have eye diseases and ophthalmologists is really off, right? There are like one ophthalmologist for every 90,000 people or something like that, right? If you think of Africa, it's even worse. So this is a specific problem, right? It's actually not a problem. It's a situation. People just live with it. People are almost philosophical about it in this country. Well, this is what happens. And nobody's thinking about it as a problem, right? Oh, this happens. This shit happens, right? People get blind. You get diabetes. We told you shouldn't be eating that much sugar, right? That kind of a thing. So we started, there were 3 of us in the early 2015s. We came across, and I'll talk about this story, but so let me postpone that. Here is the challenge of why this disease is hard to diagnose. It has micro and sub-micro features that have to be sort of seen very clearly when you take this picture of the retina, right? So when you go to an eye doctor, he gets you close to this very this camera-like thing. It's called a fundus camera, and the fundus camera takes a picture of your retina wall, right, at the back of your eye wall. And this is what it looks like. This is what a fundus image looks like. And now these are fundus images, all of which have diabetic retinopathy, but the features are so small and so subtle that it's possible that it could be a quirk of a camera or the quirk of the photography rather than anything else. And so lots of mistakes happen in the diagnosis of a disease like this. So this was the problem. In 2015, the California Healthcare Foundation released a data set of 80,000 patients, their images of their eye, and with an annotation by an ophthalmologist, which marked out that this particular eye image has diabetic retinopathy of severity 1. This image has DR of severity 2 and 3, something we call annotated data set. Now, the moment we saw this, and a lot of other people in this world, we realized that this is a gold mine. Like, somebody has put the effort and cost to put a data set together, marked it with the help of experts, and now all somebody needs to do is to train a model to do this automatically. Now, we could not have done this ourselves because we don't have access to ophthalmology. We don't understand eye diseases. But if somebody does that work for us, we can leverage it, right? And they made this data available worldwide. They opened it on a Kaggle data forum, and it was pretty much available to anybody who could just take something like this. Now, 3 years earlier than 2015, neural networks had become fairly important and very popular. They were starting to get back into traction. There was lots of interesting algorithmic innovation that had happened, and suddenly we had lots of abilities to run neural networks. I will not go into the idea of neural networks, but neural networks are basically mechanics or mechanisms for us to do interesting machine learning. And pretty much, these 4 ideas capture the idea of a neural net. So what happens is basically that you have these mathematical objects called neurons, which are basically this. Every line that you see is a layer, and every line that you see connecting them is basically a relationship, right? Now, what you do is what goes inside a neuron is that all these lines come in, you multiply the value that is coming in line with the weight, and you get an outcome, right? Then you take this outcome, you compare it with your ground truth, you capture something called a loss, and then you backpropagate that loss. You distribute that loss to neurons which were sending in that value so that you can say, here is your part of the blame. Here is your part of the blame. So that loss, which is the difference, is basically put back into the neurons in a certain way. And then the algorithm does something called optimization or gradient descent, and it's able to find the most efficient weights that is needed. In the end, what you have is a neural network where certain lines are darker than other lines because those lines are the ones where data has to flow. So that's pretty much all that a neural network does. So we used that neural network idea, and we built a model which would take that data set and give us an outcome of almost 87% sensitivity. Sensitivity is an idea which is basically the following. If you give me 100 patients who have diabetic retinopathy, I would call out 87 of them correctly. I will say that this person has diabetic retinopathy, this person has diabetic retinopathy, and so on. If you were to give me 100 people who did not have diabetic retinopathy, in our model, we could say about 65 of them correctly. For the rest of the 35, we would say, you have diabetic retinopathy, although they didn't. They did not have that. But that was not a problem because what happens is, it's okay, if somebody does not have diabetic retinopathy to say that you have because they later realize when they go to a doctor that they don't. It is not a problem. But what is a problem is that if somebody has DR and you say that you don't have DR, then you're jeopardizing their situation in some way. So you have to be very, very careful about what you're really doing. But this data set is now, which is in 2016, it was 87%, is now in the late 90s after Google partnered with a lot of eye hospitals in the country and has now built a massive system which can detect sensitivities almost like I'm saying in 97, 98% accuracies. And a situation like this, we also deployed this model in a camera, and we are working, while I'm doing this, we are also working on making sure that our model constantly improves, which basically brings me to this idea of, that once you deploy AI models, it's not the end of the story. Actually, it's the beginning. That's where, now you have to keep up and keep ensuring that what you have put out in the market can continue to work and, improve over a period of time. So once you deploy, things become more and more serious, right? So today, we are doing a lot of eye camps in India, and none of us are present, but a lot of people are getting screened, identified, and then directed to a physician or an ophthalmologist, and it's, in our minds, doing a lot of help to the community. So these are the 3 doors to AI in our minds. The first is, if you start working on insight, just like Jon Snow did, we are getting somewhere. We are already getting somewhere. And there are lots of interesting AI tools that can help take your insight and turn it into solid decision making. The second step, of course, is to organize your data sets in powerful ways to build efficiencies. And that's basically intelligent automation. Finally, the third one is, you think of completely new ways of making your data actionable, right? Act straight on that data, which is the third way to get into, different AI possibilities. That's it. Thank you so much.
Well, this was interesting. Any questions so far? You're blown away, right? Anurag, could an advice be start somewhere small, because you have the data, apparently. You have some data
Right.
with AI, with machine learning, and you can go further from there?
Absolutely, absolutely, right? I mean, data is, in my mind, synonymous to AI. If you're sitting on data, you are sitting on AI. It's like, if you have vegetables, you're sitting on food. I mean, you're going to make something of it, really, right? You're not going to let it rot, right? It's like that. So if you have data, you already have AI. Now what you have to do is start bringing value. You can't just jump to actionable data on the first day, which is possible. A lot of companies are doing that. And if you have that power and that competency and capabilities and manpower to do something like this, capital, well, one should do it, right? But there is a linear path as well. Is, in my mind, more realistic. Is you start understanding the data, it begins to help your decision-making process. There is AI there in significant ways. When we are building forecasting systems, when we are building recommendation systems, this is what we are really doing, right? We are taking out insights out of the data and making it easier for the business leader to make a decision. Then we go naturally to the next stage of it, which is like, I want specific outcome here. How do I get that? Help me organize my data to get that specific outcome. And some data scientists should be able to do that for you, organize that data to get that specific outcome for you, right? It takes a little bit more effort, a little bit more purpose, but that's possible. But then the final one is, actionable data. I want to change the way we do things, right? Not everybody has to go to the doctor. I mean, I want to solve that problem here. Now, this is changing the way we think about it. So it's disruption. So that's the third step.
Let's get practical. Let's assume we have a certain set of data, I don't know, some couple of 100 gigabytes of whatever. We know what data it is, and we have a fair feeling of how it is structured. From here to some valuable insights, what would be the time span? Is it a couple of years? Is it 2 months? Or can we, in a reasonable time, get some valuable insight?
So I remember the Android story when the data hackathon or datathon happened, right? We were just starting our BU at that time, and we were incubating, right? And we were talking about all these AI models, and I remember this very specifically because we were sitting in a room, and one of our colleagues came up and said, there is a data hackathon that's happening. Have you seen it? And I was like, no, we haven't. But let's come back. Don't go. Take your attention there. We have to think about this AI model and all that, right? And when the results came out, interestingly, and I was looking at the analytics that people had done, I was stunned because in my mind, there were at least 3 or 4 AI use cases sitting right there. And here we were in a classroom trying to figure out, what could be done. In my mind, it's not a matter of time. It's a matter of starting a process and letting it take its shape. I mean, it might be quick. It might be a little late, depending on how people are involved. But in my mind, it's possible on the first day as well. I mean, I wouldn't say that it's a linear journey, really. I mean, it happens linearly because maybe we are cautious, we are unsure, we are not sure if this will get the result. But in my mind, if the right set of people come by, the right set of data is there, things can happen.
Very good, very good. So let me pass this one question that we had in the morning with Scott also to you. So what is your take on what is the future of the data warehouse?
Okay, sure. So there are a few things that are happening in the data warehouse space. One of them is the platform itself, that is going through a massive transformation. What is happening there is that compute and storage are separating. So what does that mean? So right now, when you build a data warehouse, you have to find a platform that can store terabytes of data, but also perform very optimally when you put a query, right? So you have to do these two things. You have to store efficiently and you have to query very efficiently. Right now, so this is a problem because if you try and build a storage system which is very efficient, you sort of have to do a trade-off in the query system. So what companies have done now, and this has come about from the ideas of distributed computing, that they have segregated and separated compute and storage. So there's a lot of this things called, I don't know if you've ever heard of MPP, massively parallel systems or data warehouses. Teradata, for example, is one of those platforms which sort of guarantees very optimal outcomes when you use those warehouses. There's these other ideas of snowflake-oriented data warehouses. Now, these data warehouses, what they do is that they, instead of storing data in a row-oriented way, like you don't have storage in like a whole row after whole row after whole row, they actually store things in column. And when you put a query, what happens is that they're able to retrieve the whole column and give it to you very quickly. And partly when you're making a query, you're basically asking a question about few columns. You're not asking a question about a whole row. So they tend to be very, very fast, right? So now that's another important thing that's happening. So nowadays, MPP platforms are storing terabytes, petabytes of data and returning queries at the rate of microseconds, milliseconds. Recently, Microsoft has come up with another very interesting scenario. They have fused the data lake and the data warehouse. And so the SQL Server 2019 is a cross between a data lake and a data warehouse. And it's a very interesting technology, and it's coming out this year, right? If it has not already come out. We are exploring that technology ourselves.
So taking massive. From Scott, the data warehouse is not dead, but it will come again in maybe some altered formats, and combined with data lakes.
Absolutely. And there's another interesting thing that's happening there, right? Data cataloging is now being done by machine learning. And so when you're building these data warehouses, now the focus is on self-service analytics more than anything else. Now, what does that mean? Is that you don't need a business intelligence engineer to design this dashboard for you. Your business group can just go drag little items from rows and columns of the data set and look at your own dashboards very, very quickly, right? And so there are these very interesting tools like Looker and all, which are now being combined together with these data warehouses to do almost off-the-shelf data analytics. So going forward, my guess is that it is going to just become much more easier, much more faster, and much more intuitive to use a data warehouse, instead of having it to be like a very burdensome, long-drawn process.
You mentioned self-service analytics. We have a question from the board outside. How can we imagine that? Can you elaborate a little bit?
Sure. So typically what happens in a data warehouse is that you say that I'm interested in, let's say, I don't know, the number of sales we do every day. And so this is an interesting metric for me. So this is what we call a report. And so a BI engineer goes and they design a system to give you that specific report. Now, this process takes some time because they have to go figure out what rows and columns I need from the data set. They design a schema, and then it comes to you, right? Now, self-service analytics changes that workflow drastically. Now, instead of you asking that question, on the right side of your visualization tool, you would see that there are these interesting rows and columns identified. You can just go drag that in a very user-intuitive way and say, no, I want to see the sales versus geography. And you have the x-axis and the y-axis. You haven't employed or deployed any BI engineer for this task. And lo behold, you have analytics in front of you happening real time without any schema thing happening, without anything else happening there. So self-service analytics is this ability for people to build these reports, dashboards, and business users to participate in the story much more quickly.
Right. I hope this was sufficiently answered. Any other question to Anurag? Any AI-related question? Yeah, Scott.
I don't have a question because I'd be afraid that I would embarrass myself. But I have a comment. So I applaud you, sir, for the work you did on the retina topic because I think, and we were talking about this last night.
Exactly. Giving back.
At some point, you change your focus and you're using your knowledge and your expertise to give back in other things.
Very nice. Yeah.
Thank you.
So applause, please, and thanks a lot.